On our screen right now is another four-sided shape that we haven't talked about yet. So far, when we've talked about four-sided shapes, we've talked about parallelograms and we've talked about rhombuses. And we've also indirectly talked about squares and rectangles as well, as they relate to rhombuses and parallelograms. Today's four-sided figure is a little bit different. This four-sided figure is called a trapezoid, and a trapezoid doesn't have the same properties and rules that allow us to work with it as rhombuses and parallelograms. So down here, let's take a look at some of the properties of trapezoids. And one of the properties is that there's only one pair of opposite sides that are parallel. If we think back to the rhombus, for example, and I'm going to try to pull one up really quick on our screen here. If we think back to the rhombus or parallelogram, okay, here's a rhombus or parallelogram. We have the top and bottom here are parallel to each other, and the left and right sides are also parallel to each other. So rhombuses and parallelograms have two pairs of opposite sides that are parallel. Trapezoids only have one. And inside this trapezoid, we have four angles again. So we're still dealing with a four-sided, four-angled shape. However, those angles have different rules and properties about them as well. So in that rhombus or parallelogram, here we go, we saw that neighboring angles would add up to 180 degrees. So this angle over here in the top left plus this angle on the top right would equal 180. Or this one over here in the top left plus this one in the bottom left would equal 180. That's not true in a trapezoid. If I take a look at the neighboring angles in this trapezoid, I see here, if I focus on this top left angle right now, and I'm going to use my gold pen. So if I focus on this top left angle, this is an obtuse angle, correct? And it's more than it's more than 90 degrees. That's what classifies this as an obtuse angle. If I take a look at this neighboring angle right here, this is also an obtuse angle. It's also more than 90 degrees. If it's more than 90 degrees on both of those angles, then the resulting angle when I add them together, so something more than 90 plus something more than 90, is going to give me something more than 180. So that rule of 180 is not true in all the neighboring angles of a trapezoid. So when we say neighboring angles between parallel lines, we mean here's a parallel line, here's a parallel line. So in between those parallel lines, we're talking about those angles that are right over here. Okay? These are the neighboring angles that we're talking about. This one over here and this one over here. So here I have this obtuse angle, here I have this acute angle. So let's call this angle over here for this example, this is 100 degrees. This angle over here is 80 degrees, okay? And this is information that we're able to see and understand because they're neighboring angles between parallel lines. Opposite angles, notice that that's not a property that we have listed up here anymore. So opposite angles are not congruent necessarily, okay? Opposite angles are not congruent. And not all the neighboring angles are congruent or add up to 180 rather. It's only neighboring angles where we're focusing on one side of the trapezoid. And over here, I use a hint called the fence method. And what I will sometimes do on my trapezoids is I will draw a line through the parallel sides. So I have my parallel symbols up here, which I draw on my trapezoids a lot. And then I'm going to draw a line to cut my trapezoid in half. And what that's going to force me to do is say, okay, the two angles on this side of that line equal 180. The two angles on this side of the line equal 180. Altogether, yes, there's 180 on the left, 180 on the right, or in some cases, the trapezoid may be split vertically, so it may be 180 on the top and 180 on the bottom. But altogether, there's going to be 360 degrees inside those angles in a trapezoid. It's just the rule of 180 only applies in certain sections of that trapezoid. Let's take a look at our next example here. And here we have trapezoid ABCD, and we have to find the missing angle measurements. So we can see here that we're missing angle B and we're missing angle D because we've been given angle A and angle C so far. And I also can see that side AD is parallel to BC. These directions right here are extremely important, okay? AD is parallel to BC. What that tells me is that this line up here is parallel to this line down here. And before clicking over to this slide, I drew in the parallel arrows for us. So what I'm going to do, again, is I'm going to take that little red line drawing tool, and I'm going to cut my my trapezoid rather, in two pieces so that I focus on just one side of my trapezoid. And what this is telling me to do is focus over here. I know that angle A plus angle B equal 180. So I can do some math work now and realize that if I do 180 degrees minus 113 degrees in angle A, the remaining number of degrees is going to give me the measure of angle B. So if I do that subtraction, I get 67 degrees down here for angle B. Now, I know that angle B is 67. Does that mean angle D is 67? Definitely not. Opposite angles are not congruent in trapezoids. And if we take a look at this, 67, this is an acute angle. Angle D is obtuse. So I have to do some subtraction work again. So I see that I have 180 degrees on the right side of this trapezoid, and this angle over here is 35. So I'm going to take 180 and subtract 35 degrees. And when I do my borrowing, I'm going to be left with 145 degrees. So this angle up here is 145 degrees. Now over here, I again have trapezoid ABCD, and again I drew in that AD is parallel to BC. In some problems, you probably won't have the parallel arrows drawn in for you, so you might want to just visually put them into those problems. This way you're able to cut your trapezoid into pieces. So what I'm going to do first is I'm going to hide one part of my trapezoid. And I can find angle D over here because I know what that 58 is, but I'm not going to be able to find the two smaller angles here, which the problem is asking me to do. So I'm going to hide that part of the trapezoid. And over here, I see that I have angle A measures 135 degrees. Angle B, part of it measures 15 degrees, and another part of it is missing. Well, what I can do is think about how I have 3 parts here rather than 2 parts to get my whole of 180 degrees on this side of my trapezoid. So I have part equals 180. So I have so far 135 degrees plus 15 degrees. That's going to give me 150 degrees. And then when I do 180 minus 150, I'm going to be left with 30 degrees. And that's going to be the measure of this little angle piece right here. So I use the rule of 180 on this side of my trapezoid. Now I'm going to move my hiding piece out of the way here. I have a lot of information now that can help me out. I have 2 triangles hiding within my trapezoid. I have a triangle up top here, and I have a triangle down the bottom over here. So what I'm going to do now is I'm going to do a little bit of math work to see if I can figure out what my yellow angle is and what my red angle is. And if I do some math work, I'm going to find that within this triangle, right here, triangle BAD. Oh, it's a bad triangle. I'm going to add 135 plus 30. And I'm going to get 165 degrees in those two angles. And now that red angle up here is going to be 180 minus 165. I'm going to have 15 degrees left over for this angle up here. Fantastic. Now I have two strategies for figuring out what this angle is up here. I could do 58 plus the 15 and then subtract from 180 to get this gold angle. Or I could do 58 plus 15 and get this missing angle up here as well. So it doesn't matter which ways I'm going here because that 15 is common in both this triangle down here, triangle DCB, or I could use the rule of 180 up here. So I'm going to do 58 plus 15, and I'm going to get 73. And now 180 minus 73, I'm going to write a little bit smaller so this fits in. And I have 107 degrees. So this angle up here is 107 degrees. And I know that that's going to work with the triangle, and it works with the rule of 180 on this side. And now what I can do also is make sure that all of my angles altogether add up to 360 degrees, now that I've found every part of my trapezoid. When you're finding the angles in your trapezoid, again, be sure to check out where your parallel sides are, and you might want to draw in those parallel arrows if you can, or just find a way to cover up those parallel sides. So here on the computer on Smart Notebook, I'm able to use this hiding tool. What you might have to do is hold up a Post-it or an index card and hide part of that trapezoid so that you're able to only focus on one part of the trapezoid at a time. As always, if you have any questions, please be sure to reach out to us and enjoy finding those missing angles in trapezoids today.